Continuing on with the example we were just looking at, the graph that we came up with for our quadratic function is what we would say it's a parabola, and it's a parabola that's opening downward. That's another way of saying that this parabola is concave down on its graph. So it opens down. On both ends it goes to negative infinity. Um, that behavior is actually being determined by the sign of the leading coefficient. The leading coefficient, by leading coefficient of a polynomial function, we're talking about the coefficient on the highest power on x. And if we go back to y equals to look at our formula, remembering our leading coefficient, a, for this particular polynomial function, for this particular quadratic, is negative 1.5. That negative leading coefficient means that we're going to have, I knew going in before I even graphed this, that it was going to be a downward opening parabola. If the leading coefficient is greater than 0 on a quadratic function, the graph of that quadratic is going to be a parabola that opens upward. It'll be a concave up graph where on the ends it's going to positive infinity. This is a very handy thing to remember going forward about the behavior of quadratics. Another thing to remember about the behavior of quadratics to think about is that quadratic functions can have either 0, 1, or 2 distinct x-intercepts. There are those three possibilities. On this graph, I've demonstrated that by looking at three particular upward opening parabolas. So this is the graph of three different quadratics. And you can see that one case is for this particular quadrant, for the one at the bottom here that I'm pointing to, that quadratic has two x-intercepts. It's an upward opening parabola, the graph, and the vertex is below the x-axis, so as it opens upward, it hits the x-axis twice. It has two x-intercepts. Next, in the parabola in the middle on this graph has one x-intercept. It's opening upward, and the vertex is actually sitting right on the x-intercept. So on the x-axis. So in this case, that vertex is also, the x-coordinate of that vertex is also an x-intercept. So we have one x-intercept. And finally, the last case is that is demonstrated by this curve on top, the parabola on top there, where it's an upward opening parabola, but the vertex is above the x-axis, so that's never going to hit the x-axis. We don't have any x-intercepts. Those are our three cases in terms of x-intercepts. Of course, I could draw a similar graph with downward opening parabolas and show that downward opening parabolas can either hit the x-axis twice, one time, or no times. So no matter how you slice it, a quadratic can have 0, 1, or 2 x-intercepts. Those x-intercepts are zeros of the graph, inputs that give an output of 0. So we call them zeros. They're real numbered zeros. And those are the kinds of zeros that we're interested in with the types of models that we're dealing with in this class, the kinds of applications that we're exploring. It may be very useful to think about the x-intercepts of a model. So let's find the x-intercepts on the graph of this quadratic function, which we've already got in our calculator. It's the same example we were looking at last time. And so the first step is to find a viewing window. We've already gone through that process. If I go back to my graph, we have found a viewing window where we can see that this downward opening parabola with the vertex above the x-axis hits the x-axis twice. There's an x-intercept here, there's an x-intercept there. Just to review, before I move on, there is an algebraic way of finding zeros of a quadratic. I could use the quadratic formula, and if that quadratic formula gives me real valued answers, then those real valued answers are the x-intercepts. But in this class, we're more interested in this graphical approach. Graphically, we can find those x-intercepts by using the Calc0 method. I'm going to advance to the next slide where we're going to be using our Calc0 technique to do what's on screen right now. So let's do this. Second, Calc, and the 0 method is number 2 on that menu. So Calc0, and the questions that the calculator is going to ask here before it runs the algorithm are the same questions that it asks for Calc maximum or Calc minimum, and that is point to a left bound. And that means move your cursor so that you're pointing to a point on that parabola that's to the left, where the x-coordinate is to the left of the x-coordinate that you're looking at. So we are to the left of our 0, and hit enter to select it. And then it'll ask for a right bound. So move to the right using the cursor key, and until you're to a point on the parabola where the x-coordinate is to the right of the x-coordinate of that x-intercept that you're looking for. Hit enter to select it, and then you can just hit enter the third time for a guess. And the calculator reports back the 0. And on that graph, the x-coordinate is -2 when the y-coordinate is 0. So that's one x-intercept. F of -2 equals 0, using function notation. Now, let's go ahead and do it the second time. To find this x-intercept over here, we're going to run Calc0 again. And now we're going to move to the, I am to the left of the x-intercept, and I need to just select the left bound, but I am going to move myself over closer to that x-intercept that I'm interested in. Anywhere in here is fine. I'm to the left of my x-intercept. So hit enter to select it, and then it asks me for a right bound. So now I'm going to move to the right on the graph until I get to the other side of the x-axis, where this point that I'm pointing to right now has an x-coordinate that's to the right of the x-intercept that I'm looking for. Hit enter to select it, and then hit enter the third time for the guess. And the answer is x equals 8 when y is equal to 0. So in function notation, f of 8 equals 0. So we found the two x-intercepts. We can say that the location of those x-intercepts on the graph of f are at x equal -2 and x equal 8. Or you can report it to someone by giving both coordinates. The point -2, 0 on the graph is an x-intercept, and the point 8, 0 is an x-intercept. X-intercepts have y-coordinates of 0.